Okay. Hello and welcome to our senior project where we will be presenting our remediation methods on the Puddingstone Reservoir. Now put your hands together to meet the team. We have Allison Richter as our remediation lead. Next we have Jenny Perez as our administration lead. Sam Hernandez is our environmental lead. Adrian Gallinari as our geospatial lead. And lastly we have Nevada Ramirez as our project manager.
I'd like to introduce our faculty advisors, Dr. Palomo and Dr. Mora. It's thanks to them that our team has stayed motivated and eager to produce results. I'd also like to thank our industry advisors, John and Ben, and thank them for providing their priceless industry experience.
Today we will be discussing background information, site details, environmental impact, contaminant inventory, risk portfolio, remediation methods, and lastly the conclusion.
So here we have a quick visual of Bonelli Park, Puddingstone Reservoir, and some of its surroundings. The reservoir is located in the city of San Dimas to the northeast of the 57 and the 10 freeway interchange. Some of the key points of interest are Walnut Creek, the swim beach, and then we'll be coming up on a second is Live Oak Wash. So again, this is just to give you a general geographical context of the area and kind of what Puddingstone and its overall surroundings look like. So we're just going to jump into our historical context next.
Beginning in the 1880s, the population size and agricultural industry in the greater Los Angeles area were booming, but also plagued by frequent flood events, particularly in 1913 and 1914. Massive flood events underlined the need for a flood control plan going forward. As early as the 1920s, companies began bidding on dam projects in the San Gabriel area, including what would eventually result in the Puddingstone Reservoir. The map on this slide was published in the LA Times in 1922, depicting an early conception of the Puddingstone Reservoir.
The Puddingstone Reservoir was constructed in 1928 as a part of a flood control program taking place in Southern California. The purpose of constructing the reservoir was to impound water runoff and replenish the groundwater table in the area. In 1953, the recreational and fishing area was established at the reservoir, and the lake became a recreational fishing area for the community. In 1959, the city of San Dimas was approved to purchase excess water from the reservoir based on average water levels of the lake and use it to benefit the surrounding community. In 1970, the Joint Powers Agreement was created between Los Angeles County and the cities of San Dimas, Covina, Glendora, Pomona, Laverne, and Walnut. As a result, the Puddingstone Reservoir Regional Park Authority was established. The Puddingstone Reservoir is a part of the Frank G. Bonelli Regional Park, which is an 1,800-acre facility. The reservoir is a 250-acre lake within Bonelli Park. The park contains 14 miles of multi-use trails available for use by visitors to the park and acts as a green space for the community. People in surrounding areas are also able to use the park and the lake for recreational activities, such as boating and jet skiing, picnics, walks or hikes, fishing, and biking. Annual activities such as concerts, fishing tournaments, water sports, triathlons, and cultural events also take place at Bonelli Park. The park also has amenities such as barbecues, boating areas and boat launches, kayaking, children's play areas, concession stands, equestrian centers and trails, softball fields, and campsites. All of these serve to benefit the park visitors. To this day, people still use the lake recreationally. However, contamination within the lake poses a threat to the community and hinders its use as a recreational space.
The reservoir receives contaminants from public, construction, and industrial sources, and there are also existing contaminants from the past that we have been able to identify and quantify. These pose serious health concerns for the local community and ecosystem, including mercury, cancer-causing chemicals, and harmful algal blooms, which can result in potentially deadly water conditions. The graphic on the left shows different general categories of contaminants, and the picture on the right is not from Puddingstone, but it is an example of what harmful algal bloom conditions can look like.
In order for residents to feel safe using the lake and eating its fish, we must remediate the contaminants that are not in compliance with EPA standards in order to fulfill our duties as civil engineers. To complete our tasks, We will be referring back to the ASC Code of Ethics, which clearly states in Code 1A, first and foremost, protect the health, safety, and welfare of the public, and Code 2B, which states consider and balance societal, environmental, and economical impacts along with opportunities for improvement in their work. Remediation would improve the overall health of the environment in the area, as well as the community that uses the reservoir, fulfilling these two ethical codes as engineers.
Now we're going to talk a little bit about the watershed hydrology. The lake sits 940 feet above sea level with a 250-acre surface area and a 24.6-foot average depth. The main inflow is at Live Oak Wash at the northeast end, and the main outflow is at Walnut Creek at the northwest end. Walnut Creek is an urban stream in the San Gabriel Valley of Southern California and is a tributary of the San Gabriel River.
After finding the hydrology of the immediate watershed, we wanted to understand the extent of the inflows as well as the overall watershed. Once we performed a watershed delineation using topographic maps, it became apparent just how massive the watershed for Puddingstone actually is, taking up an area of around 14.7 square miles and encompassing the majority of the city of Laverne. This informed us of the horizontal dimensions for the watershed and led to the creation of a vertical extent via the shaded relief map on the right. One aspect we noticed was that the vertical difference between the northern end and Puddingstone itself was just over around 1,900 feet, which would provide any and all water the energy needed to make its way to the reservoir. From there, we wanted to see the pathways that the water takes to encompass this overall watershed. So here we have the main inflow paths laid out within the Puddingstone Reservoir watershed. Some things to note include 3 distinct pathways that travel up the watershed, with the main storm drain channel around 4 miles in length, taking up the western side, Marshall Creek around 6 miles, funneling water from the middle, and Live Oak Wash around 5 miles in length, splitting towards the eastern side. This informed us of the environments that the water travels through as it makes its way to Puddingstone, passing by numerous residential areas, a metropolitan water district facility, and eventually an industry park located north of Brackett Field Airport. These varied environments pose a risk for contamination, especially when sections of these inflows, particularly at the industry park, were built as open channels. Our final models were done to analyze the conditions of the immediate watershed, and what became most apparent through the topography, as seen in red on the left, was the fact that Puddingstone is surrounded by sources of runoff. The reservoir sits downstream most notably from a residential community to the north, Brackett Field Airport, East Shore RV Park, and Benelli Park itself, all of which add potential sediment, contaminant, and organic material sources. Lastly, the water currently sitting in Puddingstone has not yet reached a volume to warrant opening the outflow through Walnut Creek, forcing all the water that does arrive from the inflows and runoff, sit and lose energy, accumulate, and deposit its transported material onto the lake bed, particularly into the trench-like 30-foot deep depression at the northwest section.
For our environmental concern, we've identified both our task and goal. Our task is that the reservoir is impaired by high organic matter, low dissolved oxygen, mercury, and PCBs. This downhill effect has an impact on recreational use, especially now in the time of COVID-19, with such few areas and activities that are available to the community. It is important that we reaffirm our commitment to areas that the public used to enjoy. Our goal is to remediate the reservoir via water remediation.
Our methodology for this project is as follows. First, we will evaluate the contaminants identified in the EPA's Los Angeles Area Links TMDL. Next, a risk assessment will be done to identify the contaminants that pose the most risk to human health and safety, which will order our priority for remediation. We will also consider other perspectives, not just engineering, including the social and economic costs of our remediation. Then we will examine remediation technologies and case studies where these technologies have been used and adapt them to the unique conditions of Puddingstone Lake. Finally, we will prepare our findings in a report and presentation for consideration of adoption by the Los Angeles Department of Parks and Recreation and LA County Public Works.
As Ed and Vianney mentioned earlier in this presentation, Puddingstone Reservoir is contaminated, and in order to create a healthy environment, we need to remediate it. Now, the contaminants listed here are outlined with their concentrations and in which medium those concentrations are found in. To create a more comprehensive understanding of the contamination, we need to truly grasp what these contaminants are.
The first contaminant that affects the lake is organic matter. It impedes the removal of iron and manganese, which leads to harmful effects to the ecosystem. The impact that high organic matter has on the environment is poor odor, degradation of the taste, and clarity. It also leads to bacterial regrowth that is hazardous to the local ecosystem. High organic matter is the residual matter that is left from carbon-based organisms, also known as the fecal matter left by animals and other wildlife.
The second contaminant with high priority that affects the lake is low dissolved oxygen. The health concerns this causes are stress in aquatic life, declining in the health of organisms or even their death, and it can lower the water quality of the lake. The impacts on the environment are that it can lead a whole body of water to die, and it can pose a threat to aquatic ecosystems as a whole. Dissolved oxygen is a measure of how much oxygen is dissolved in the water, and therefore the amount of oxygen available to the organisms in the water. The amount of dissolved oxygen can show a lot about the water quality. Low dissolved oxygen can result from excessive algae growth, which leads to poor water quality.
Our next contaminant is mercury. One of the main health concerns is that it's a neurotoxin. Another concern is its ability to bioaccumulate and biomagnify up the food chain, like the picture shown on the top right. This leads to a major problem of humans consuming the toxin through contaminated fish, with pregnant women and children being at the highest risk because of their high exposure to mercury can lead to developmental and neurological defects. We also have men facing increased risk of cardiovascular disease with this consumption of this contaminated fish. Mercury also negatively impacts the environment by threatening the aquatic ecosystems. We have fish facing a big threat, with piscivorous fish facing the biggest threat, and piscivorous fish are just going to be fish that consume other fish. And with their mercury exposure, they slow their embryonic development, and it also damages their tissues and their cells. And ultimately, mercury is a naturally occurring element that can be found in as many different species throughout the environment, with methylmercury being the most dangerous of them all.
So the final contaminant that we want to focus on today is polychlorinated biphenyls, or PCBs. These are classified by the EPA as an A2 carcinogen. So this means that it's a probable human carcinogen. And studies done on animals have shown that can affect their immune, reproductive, and endocrine systems. So this is why it's really important that we properly treat PCBs. In terms of impact on the environment, PCBs tend to get into the environment due to improper storage, spills, or leaks from electrical equipment, and they're also hydrophobic. So this means that they have a really low solubility in water, and they look to solids such as sediment and skin to stick to. So this leads to residue in the sediment that bottom-feeding fish in Puddingstone eat, leading to bioaccumulation and higher concentrations of PCBs up the food chain. So PCBs are man-made organic chemicals that were manufactured from 1929 until they were banned in 1979. And they're mainly used in appliances and electrical equipment, with some of them in use today. So that's why we still see the presence of PCBs in our environment.
The community is our top priority. Since Bonelli Park is a recreational space, it is crucial that we prioritize their health and safety. The community visits Bonelli Park expecting it to be safe, clean, and appealing. In order to uphold the population's well-being, we must prioritize three foundational pillars: the community, the economy, and the environment. Without these three pillars, we would not be able to fulfill our duty of protecting the community's well-being according to Code 2B from the ASC Code of Ethics mentioned previously.
To begin, we will be understanding the community pillar. Since a community's mental health is linked to their physical health, we must prioritize it. In the past year, the number of mental health related cases has spiked, such as stress, anxiety, depression, insomnia, anger, and denial. Being surrounded by nature will help as a coping mechanism. Studies have shown that distressed people experience better moods after spending time outdoors. Having access to a green space can increase the life expectancy of 13 years. This will be most beneficial for the Black and Latino communities, especially because these two communities have suffered from environmental racism. South LA has a life expectancy of 77 years, and Beverly Hills has a life expectancy of 90 to 103 years, while being less than 15 miles away from each other.
The second pillar of the community's well-being is the economical pillar. Benelli Park already offers many job opportunities to a wide range of applicants, including lifeguards, cashiers, and maintenance workers. Through the implementation of our project, we would be able to encourage job growth in the community, including more or specialized maintenance workers, aerator installation teams, engineering teams, and possibly more throughout the project as well as after the project is completed. Finally, our project would attract more tourists through Benelli Park, since Benelli Park would be more clean and more appealing. All of these things encourage financial security within the community, thus bettering the well-being of the community itself. Finally, in order to protect the well-being of the community, we must protect the environment in which they live in order to protect their health. Living in a contaminated environment is not healthy. As mentioned previously, mental health and environment have a very strong correlation, so maintaining a clean environment would benefit the community. Also, wildlife and plants live in this environment, so we feel the urge to rehabilitate the environment for the benefit of the ecosystem as well. Again, the community's well-being is our topmost priority. With that being said, let's take a deeper look into the contaminants in which we prioritize.
Now that we have an understanding of what these contaminants are and their respective health concerns, our next step was to create a comprehensive risk assessment that could quantify the overall risk associated with each contaminant. This risk assessment factored in an engineering approach along with the 3 pillars of community well-being. In the upper right side of this slide, the gauge graphic defines how we rated each contaminant based on the 3 pillars, with green signifying low risk, orange signifying medium risk, and red signifying high risk. The community pillar pertains to how the contaminants affect the community and the use of the reservoir. As you can see, high organic matter and low dissolved oxygen are considered the highest priority as they directly affect human health and the aesthetic value of the reservoir. Next, the economic pillar pertains to the economic feasibility and cost effectiveness of treating each contaminant. In this category, mercury and PCBs were attributed the highest risk, as the remediation would be costly, but may not be cost effective as their threat to visitors is relatively minimal. Finally, the environmental pillar pertains to the environmental impact each contaminant has and the severity of its effects on the wildlife and ecology of Puddingstone Reservoir. Environmentally, the high organic matter and low dissolved oxygen pose the greatest risk to the ecology and wildlife of Puddingstone Reservoir. Now, let's take a look at our contaminant priority.
Our highest priorities are dissolved oxygen and high organic matter, as shown in the risk assessment explained by Sam previously, as these can affect the odor and the color of the lake by fostering algae growth, decreasing its aesthetic and recreational value. Mercury and PCBs are the next priority, as they put recreational anglers at risk when they consume the caught fish. As people do not rely on the lake as a primary protein source, the risk is relatively low when compared to high organic matter and low dissolved oxygen.
As we have shown in previous slides, now is the time to act and make positive changes at the Puddingstone Reservoir for the benefit of the community. The proposed methods of remediation are aeration diffusers, a rehabilitation channel, and riverbank filtration. Aeration diffusers will focus on aerating the water, adding dissolved oxygen back into the reservoir. The construction of a rehabilitation channel will remove contaminants such as high organic matter from the water through the addition of a coagulant to the system. Riverbank filtration focuses on remediating the water through the cleaning of sediments in the bed of rivers and lakes. This method of remediation will focus on the removal of mercury and PCB from the reservoir. We will expand upon these remediation methods in the next few slides.
So as Allison touched on, aeration diffusers work by pumping surface air into the water. This infuses oxygen with the lake and thus increases the dissolved oxygen and aerates portions of the reservoir. The diffuser devices are powered by a central air compressor, which uses a 3-phase 460-volt motor. These diffusers act as subtle features, displaying a small circular area of bubbles during their operation. Tubing that connects the device to the compressor can be concealable and hidden from public view, as well as be placed deep enough in the water to avoid boat propellers. The diffusers shown on the right are designed with openings to create over 100 million bubbles, 1/8 of an inch, to increase effective air mixing and efficiency compared to larger bubbles. Therefore, the addition of several of these diffusers throughout the reservoir would increase the concentration of oxygen throughout. As far as our proposed locations go, the location of our air compressor would be towards the northeast corner of the lake near the inlet. This location is ideal based on the lakebed topography. its ability to run tubing downslope, and the proximity to existing power lines towards the northeast. Our primary focus is on lake depths greater than 25 feet, since oxygen concentration levels tend to drop past that threshold, as shown in the proposed distribution on the top right. Simple fencing can be placed to keep people from tampering with the device. The compressor itself would contribute very little to ambient noise, since it is typically capable of running silently. It can also be run automatically with a variable operation speed via a remote monitoring function. The tubing that connects the compressor to the manifold at this location can be buried to avoid any potential public tripping hazards. Both the compressors and tubing are placed on stilts that raise the manifolds 1 foot off of the lake bed surface, ensuring minimal uplift and resuspension of bed soils and other deposited material. The manifolds can all run from the same central location. Therefore, the only challenge is simply the distribution of the compressors themselves. For our cost analysis with currently available dissolved oxygen data, we're looking at a capital expenditure around $250,000 to $300,000. For the long term, there is an expected risk of an algae bloom after installation and starting operation. However, this will dissipate within the first 4 to 6 weeks of continuous use. The diffusers have component warranties lasting over 5 years, and this system overall will have around a 30-year life expectancy. For operation and maintenance, this involves ensuring that the system is running as optimally and uniformly as possible, which is done through monitoring the pressure gauges and valves that come equipped with each series of manifolds. This results in costs of around $500 to $1,000 per year, with an average around 30 minutes of maintenance per day, and an energy demand of around $31,000 per year.
Puddingstone rehabilitation channel will be used to remediate some of the contaminants in the lake water by coagulation, primarily high organic matter. Lake water will be pumped over a waterfall and enter a channel with a proposed dimensions of 315 feet long, 8 feet wide, and 3 feet deep. Polyaluminum chloride will mix with the lake water, a coagulant, taking advantage of the kinetic energy gained by going over the waterfall. Water and precipitates will flow to the end of the channel, where a depression will allow all the precipitates to accumulate. The flocks may be then pumped out of the depression and removed via truck on a twice-monthly basis. The preliminary design parameters are as follows. Using a design flow of 2.5 cubic feet per second, the preliminary design for the system will treat around 5 acre-feet of water per day and utilize 187 kilograms of polyaluminum chloride per day, coagulating approximately 30% of the organic material in the water. This is based on a polyaluminum chloride case study on the Luan River in China and vendor data. Jar tests will be needed to be done on the reservoir in order to more accurately determine the dose and other design parameters. The current proposed location for the channel is on the west side of the reservoir near the dam and boathouse. The inlet and outlet of the channel will be on the north side of the peninsula. A 600-gallon storage tank for the polyaluminum chloride will be located near an access road and parking lot for easy refill every 2 weeks. One of the hazards that we have identified with this site is a potential impact to Puddingstone dam stability due to the excavation and the increased pressure on the soil due to the channel and concrete. The project will need to be done in close collaboration with the Army Corps of Engineers in order to minimize risk to the dam. The rehabilitation channel cost estimate is still being updated, but so far we have been able to produce an estimate for the earthwork and materials cost portion of the product. We have found that we will be excavating around 325 cubic yards of soil and for a 315-foot long channel. And for precast concrete, we're looking at a cost of approximately $600,000. For our operations and maintenance, we are analyzing the option of cleaning the channel every 2 weeks, with the cost of flocks and coagulant per month and ends up being around $3,500.
For the proposed method of riverbank filtration, we're looking to get this done through focused dredging. We want to focus our efforts where the contaminants are the most concentrated. The contaminated soil would be excavated from these high priority locations and properly disposed of. And these proposed locations would be the major inflow near Live Oak Wash and the southern outflow by the swim beach. The swim beach is designated a high priority location because of the people that swim in the area. As mentioned previously, PCBs are hydrophobic and we want to minimize any potential human exposure. Here we have our initial cost estimate for the proposed dredging portion of the project, which brings us to just over $1 million for dredging and disposing of almost 37,000 cubic yards of soil. And we would be treating around 345 acre feet of the reservoir.
To address the main goals of remediating Puddingstone Reservoir, our team recommends the following solutions. Water methods are shown in blue and the soil method is shown in yellow. Aeration diffusers are a strong fit for adjusting low dissolved oxygen, which is a critical water concern. They're non-disruptive and have low maintenance requirements. Additionally, a rehabilitation channel targeting high organic matter is an effective solution as it continues to treat river contents or reservoir contents for an extended period of time. It also has a small footprint and requires only moderate maintenance, such as periodic removal of flocculants and restocking of polyaluminum chloride supply, as mentioned before. Lastly, to address soil impairments, our team recommends focused dredging. While it initially comes with a relatively steep cost and disrupts some of the functions of the lake, it is the remediation method that will provide the most immediate benefit in terms of removing contaminants. To minimize the disruption to the community, our team recommends beginning the dredging during the off-season when swim beaches are closed.
In addition to our recommended remediation methods, I'll be going into some BMPs. We're looking to get this, we're looking to implement some pet waste stations near the rehabilitation channel and within the park. A small pet fee would also be proposed to help cover the maintenance costs of these stations. Further water contamination is easily avoidable with an adequate amount of these stations, and we also want to use the implementation of our proposed methods as an opportunity to teach the community about what we're doing. So we would install signs near the rehabilitation channel and aeration diffusion stations explaining what they do and why they're helpful.
The California Environmental Quality Act and the National Environmental Policy Act, known as CEQA and NEPA, establish standards that evaluate the impacts that all possible stakeholders and the public could sustain as a result of a project's implementation. In our case of a proposed environmental remediation project, we are required to consider major factors such as, but not limited to, aesthetics, air quality, biological resources, hydrology and air and water quality, noise, recreation, geology and soils, land use and planning, and public services. In detail, the ramifications our remediation could have on each factor. Following both NEPA and CEQA requirements during our environmental impact reporting will allow us to seek both state and/or federal funding for our remediation project.
There are many funding sources that are applicable to this project. First, Measure W, also known as the Safe Clean Water Program. Measure A, which provides for updates of recreational parks in LA County's Parks and Recs Prop 68 that is dedicated to the improvement of regional parks and their facilities. The State Water Resources Control Board also has the 2022 Clean Water Act, Section 319, which is to reduce and mitigate the effects of non-point source pollution in state waters. The CRWSF program, which finances eligible projects to restore and maintain water quality. And the EPA has multi-purpose grants, which funding can aid cleanup and remediation efforts of contaminated water sources, water systems, and lands.
Now we will list the permits needed in order to properly go through with this project. So the City of San Dimas Regional Planning Division requires an encroachment permit. The California Department of Fish and Game requires a stream bed alteration agreement or a 1603 permit. The Regional Water Quality Board requires a National Pollution Discharge Elimination System permit. The U.S. Army Corps of Engineers requires a Section 404 permit. The National Marine Fisheries Services requires a consultation with them due to the Section 404 permit mentioned above being a federal permit. And lastly, the South Coast Air Quality requires a Form 400 CEQA.
Now I'll go over our project timeline. The project will be broken up into 3 main phases: the design phase, pre-construction phase, and then finally the construction phase. We have an estimated start date of August 30th of this year, and we'll be starting first with our design phase. This design phase includes a community outreach period, preliminary design, and a final design. We estimate this will take about 7 months for this period. Our next phase is our pre-construction phase, which will consist of permit acquisition and bidding. This will also take about 7 months. Our next phase is going to be our construction phase that is broken up into 2 main phases. Our first phase will be for the construction of the aeration diffusers and the rehabilitation channel, which will be being built simultaneously. This process will take about 1.5 months. The second phase will be for focused dredging and will take less than a month, which brings our final date of completion to February of 2023.
As a reminder, it is imperative that we restore the reservoir through the previously mentioned remediation methods. By doing this, we will enhance the living conditions for aquatic life while giving the community a safer, greener, recreational space.
So what we intend in remediating Puddingstone Reservoir is we hope to improve the overall quality of the lake, positively impact the community that use the park, and work towards decreasing the bioaccumulation of contaminants in the fish.
Before we conclude our presentation, we would like to thank those who helped us in completing this project. We would not have gotten this far without their support and assistance. With Jose Cupirelli, Richard Dennis, and Marcus Gubba-Rinner. We have open a great audience. Thank you for joining us today for our presentation on remediating the Puddingstone Reservoir. Now we will love to address any questions you may have.